So after our algebra review, we're ready to take a look at one of the example problems from your homework. Okay, so let's look at number 1. The question says, a solution was prepared by dissolving 18.3 grams of KNO3 in 75.0 milliliters of water. What is the weight per volume percent of this solution? Okay, now, the first step in our procedure for solving all of these problems is to write a table of knowns and unknowns. This is how we do that. Okay, I'm going to go through my problem and I'm going to identify every time I'm given some mathematical information. Here we have 18.3 grams of KNO3. And here we have 75.0 milliliters of water. What is the weight per volume percent of this solution? Okay, so I really have 3 pieces of information here. The third piece of information is that weight per volume percent. Now, in some problems, you'll be given extra information that's not useful to the problem. But why would she be so tricky? That's really a jerk thing to do. Well, it's part of critical thinking to identify what is extraneous information in any given problem. Because in real life, we're not given all of the information that we need in a streamlined fashion right from the get-go. Sometimes when a patient comes in and he or she gives you his full medical history, he's telling you things that aren't pertinent to his condition at the moment. You know, maybe he broke his ankle 3 years ago and now he's got something, he's got an infection in his finger. Extraneous information that doesn't have any bearing on his present condition. So that's what we're learning when it comes time for that. So don't get frustrated about it, it's life. Okay, so let's start from the end. What is the weight per volume percent? In other words, weight per volume percent equals question mark. If you can figure out what you're looking for, you're halfway there. Okay, so now we also have here, we have a weight. Oh, 18.3 grams KNO3, that's a weight. Okay, is that weight of our solution or weight of our solvent or weight of our solute? Well, it's weight of something. We don't know yet. And then we're given a milliliters, a something milliliters. Okay, milliliters is what kind of unit? Well, that's volume. So we've got a weight and a volume. Okay, now the KNO3 is what is called the solute. How do I know that? Because it doesn't say that that's the weight of my solution. And because we're putting it into water, water can never be a solute. So therefore, we know that we have a weight of our solute there in the KNO3. Okay, so I made my list of my table of knowns and unknowns. This is exactly how I want you to do it. I want you to put it on the left side of your paper, right underneath the text of the question. Now, the second step is to write down the formula you need. So you want to look at your formula sheet. Is there anything in there that has weight per volume percent? Well, the weight per volume percent formula, right? Is this the formula you want? No, that's the weight per weight percent formula. We haven't even talked about that. So we're not going to write that down. So what I want you to do is write out all of what you see on the formula sheet. Weight per volume percent equals weight of solute in grams, you should write that down, divided by your volume of your solution in milliliters. Okay. Now, the next step that we need to do is we need to solve for our unknown. Whatever has the little question mark beside it in your table of knowns and unknowns is what needs to go by itself on the left-hand side of the equation, of your formula. Here we're looking for weight per volume percent, and here it is all by its lonesome on the left side of the formula. Perfect. We don't have to do anything. So now step 4 is plug and chug. That means we just take what's in our table of knowns and unknowns, plug it into the formula, and chug those numbers on our calculator. So we have 18.3 grams KNO3 divided by 75.0 milliliters. Is that what we're supposed to do? No. The reason why I purposely made this mistake was to get you to think about what I did wrong. Notice how I left this whole section blank here? And notice how this has a more defined label? This wants me to write the volume of the solution on the bottom of this equation. Is this the volume of your solution? Well, how do you know what's the volume of the solution and all that other nonsense? The solution equals solute plus solvent. What do you have here? Is that solution? Well, no, pure water is just the solvent. So that 75 milliliters is the volume of your solvent. Okay, you might be thinking, oh geez, that's awfully nitpicky. Why does that matter? Well, this is why. This and this are not the same thing. In order to calculate the volume of our solution, we have to take the volume of our solvent plus the volume of our solute to get 93.3 milliliters, not 75.0. Well, Michelle, where did you get that 18.3 from? That's not milliliters, that's grams. Well, we are simplifying the fact that the density, remember we talked about this week 1, lecture 1, density equals mass divided by volume. And if you have a density of 1.00 grams per milliliter, that means your number of grams is exactly equal to your number of milliliters. Suffice it to say for you that grams is the same as milliliters when you're converting between the two. You'll only need that for these problems. You will only need that for the weight per volume percent problems. Do not do this for any other problem than weight per volume percent. You will get really screwed up. Okay, so that's how we find the volume of the solution. That's why I did this problem as an example, because it's tricky. Okay, so you get an answer, and from out of your calculator you get 0.196. Is this right? You want it in percent. So you should write 19.6%. This is your unit. You know, we don't normally think of the percent sign as a unit, but in chemistry land we do. Now, do we have the correct number of significant figures? That should always be your final question. Here we have 3, here we have 3, so our answer should have 3. Okay. If you are lost, do not panic. We will keep doing these. How many grams of sugar, this is number 2, how many grams of sugar would you need to prepare, how much How many grams of sugar would you need to prepare 20 milliliters of a 0.9% weight per volume solution? Okay, so we have grams of sugar, 20 milliliters of 0.9% weight per volume solution. This is something that you probably see very commonly, this actual solution of 0.9% sugar or glucose solution. This is the isotonic solution. We'll talk about that later. Okay, our table of knowns and unknowns. How many grams? Therefore, grams equals question mark. Okay, but we can describe this grams a little bit better. Sugar. Is sugar going to be your solute or your solvent? There's only one solvent for you guys, it's water. So everything else is solute. So instead of writing grams, we can write grams solute equals question mark. That's really, really helpful. Okay, then we're given this volume. And now this time, is that 20 milliliters your volume of your solution or of your solvent? Well, here it says to prepare 20 milliliters of a something solution. So this is volume of a solution, and that equals 20.0 milliliters. And now it's imperative for you guys to make sure that when you're recopying that problem information into your table of knowns and unknowns, that you always write out the exact number. Don't leave out or make up any new significant figures, because it'll cause you problems when you get to the end. Okay, and then our last piece of information is that weight per volume percent. So we have weight per volume percent, and now this time that's not what the question mark is. That we have a value for that. That is 0.9%. Okay. Now, whenever you have to use a percent as a number in a problem, in your table of unknowns and your knowns and unknowns, I want you to convert it to numbers right away. So 0.90 in number form is equal to 0.0090. That's the number that corresponds to 0.9%. Okay, now step 2 is to write that formula that we need. And it's the same formula from that last problem. So we have weight of our solute. I called it gram solute, weight solute, same thing, divided by the volume of our solution times 100%. Okay, so now, step 3, the most important step. You need to solve your formula for the question mark. Who is our question mark this time? We have to solve for weight of solute. Okay, so in order to get this by itself, we're going to have to get rid of the volume of our solution on this side of the equation. In order to do that, we are going to multiply both sides by volume of solution. That'll give us this resulting formula. Volume of solution times the weight per volume percent. That's your concentration of your solution, is equal to grams solute. Now you've got this by itself, and that means that all you have to do now is plug and chug. So that equals then the volume was 20.0 milliliters times that percent. And you should get an answer of 0.9%. grams of sugar. So what's the point of this problem? This is telling you that in every 20 milliliters of that 0.9% glucose solution, you need to have 0.18 grams of regular sugar. That's how much, that's the dosage you're delivering to your patient in every 20 mils. Okay, do I have the right sig figs? Well, yes, I only have 2 sig figs, but look here. That 0.90 only has 2. So my answer should only have 2. Okay. There's only one other weight per volume percent problem on the homework, so I'm only going to do 2 examples of that kind of problem. The next 2 types of solution calculations are almost exactly the same, so we're just to keep doing examples of those, so you have some practice of the different types as well. Alrighty. V over V percent. In English, this means volume per volume percent. Now, the formula for volume per volume percent equals the volume of your solute divided by the volume of your solution times 100. So in this case, you're going to be making up solutions by adding a liquid to a liquid. And remember that if you're not given volume of solution, like let's say you're given volume of solvent, volume of solute plus volume of solvent equals volume of solution. Let's do an example. This is number 3 from your homework. An antifreeze solution was prepared by dissolving 250 milliliters of methyl alcohol in 600 milliliters of water. What is the concentration in volume per volume percent of this solution? Okay, this is the table list of knowns and unknowns. We have this information, and we have this information, and we have this information. I really like to start with my unknown first. It helps me to put the problem in perspective. If it's more convenient for you to work from left to right through your problem, through the text of your problem, that's fine with me. I don't care what order the table of knowns and unknowns is in. Doesn't matter at all. Whatever works for you. So I'm going to start with that volume per volume percent. Okay, so remember what we said? Water can only ever be the solvent. Let's do that one first because that's easy. So the V of our solvent, volume of our solvent, is 600. Don't forget that. Milliliters. Oh, and you better have your unit in all of your knowns and unknowns, because if you don't, you lose points for that too. And then that other piece of information. Now, there are only 2 possibilities that this could be. Either it's going to be your solute or your solution. So we already have the solvent. In this case, it's methyl alcohol. It doesn't say solution. Therefore, it has to be our solute. Okay, we've got our table down. Let's write our equation. Now I am going to write here solvent plus solute because I know that I don't have a volume of solution. Okay. Plug and chug. My problem is already solved for that volume per volume percent, so I just have to plug and chug. So volume of solute is 250 divided by solvent plus solute. And you get an answer which, was this really number 3? Well, I'm sure you can calculate that answer. 250 divided by 850, something like 0.25 or something. Make sure that it is in percent. And how many sig figs should you have? You should have 3 sig figs. Oh, there it is. 29.4%. So you know how I made my threat before about giving you double the homework? This is the actual homework that I took those questions from. And this isn't the acid-base stuff that's for next Thursday. This is how many pages there are. These are back to back. 2, 4, 6, 8, 10, 11. 11 pages of just solutions. You only have 6. So, no complaint. Okay, so this is what we get for the answer. You should have 3 sig figs, and that's all you need to do. Okay. The final type of percent kind of solution is the weight per weight percent solution. Weight per weight. This is the concentration that you're going to see most of the time for those topical ointments that are prescribed. So if you have a 1% hydrocortisone cream, that means you have 1% hydrocortisone in your solution. Okay? So that's where this comes from. So the formula on your sheet looks like this. Gram solute, because grams is weight. Grams and weight are the same thing. Don't get confused. I know that it's sometimes tricky when we use interchangeable terminology. But I figured if I wrote this stuff down a little bit better for you, it would become a little bit easier to handle. Okay, weight per weight percent solutions are exactly the same as volume per volume percent, except that you have a different unit. So you have gram solute divided by gram solution. Just like in volume per volume, it's volume solute divided by volume solution. Same thing. Okay, this is number 20 on your homework. I think this is page 3. If 4 grams of NaOH is dissolved in 96 grams of water, what is the weight per weight percent of the solution? Okay, we've done 3 examples together already. I want you to pause it and try to work through it yourself. Now, you might be confused, well, Michelle, grams solute is not 96. No, I know it's not, and I'm sorry that I didn't do it linearly, but I wanted to show you that addition is cumulative, which means it doesn't matter what order you do it in, as long as you do all the adding at the same time. So it doesn't matter that I switch these around here. 96 plus 4 gives you the same answer as 4 plus 96. I know that's basic math. Some of my undergraduate students have a hard time with that, so I just wanted to bring it up to you. Okay, this is the last example of these percent calculations that I'm going to do for you. If you wanted to practice this concept, I would go through and take a look at all of the problems that have a percent calculation in them on your homework, and it might be a good idea to do a couple of those just to reinforce the practice concepts. If you didn't work the examples 1, 2, and 3 right on your paper, you might want to try to go back and work them on your homework paper that you're going to hand in, so that you know, doing it again, repetition for emphasis, hopefully that practicing will help you.